Hi everyone and welcome back. Today we will solve a problem of dividing a data sequence of length d by a generator vector of length d. In our case here, the data sequence is consisting of 10 bits, that is to say the length is 10, and the generator matrix has a length of, or the generator vector has a length of 5. So now the remainder will have a length of 4, simply length of g minus 1. This is the rule always, okay? Excuse me. So now we will start with the first 5 bits. Why? Because simply length of g is 5. So because this sequence of length 5 starts with a 1, so the result will be 1. We put a 1 at the fifth place, which is the length of g, in fact. 4, 5. Okay, 1. Now when I multiply back 1 back into g, I'll get the sequence g itself. So I reproduce it under d. Now, great. So now we have divided and we have multiplied back and we have rewritten d. At this stage we do a simple XOR operation. So here we get 0, 0, 1, 1, 0. Do not forget that in XOR the result will be 1 only if the two bits they are different from each other, like these two, they are different, so the answer will be 1. Okay? The answer is 1, as we can see. However, if the two bits are similar, like this case, the answer will be 0, or the other case where they are similar, the answer will be 0. Great. After having done this, we drop the next 0 down and we redo the operation once again. So now I drop down the 0 and then I redo the operation with these 5 bits. In fact, in D I have shifted 1 step to the right. Okay, great. Now my sequence starts with a 0, so when I divide that by g I get a 0. I record it there, and when I multiply back into g I end up having all zeros. Now we do repeat the XOR. For similar ones the answer will be 0, and for different ones the answer will be a 1. Great. Now we will drop the next bit like before here, so I put the 1 there. Now if I divide that by g, the answer will be 1. I multiply 1 back into g, I get g itself. So great. Now once more we do the XOR operation here, and then we have the sequence. Great. Now we repeat once more. We get the next bit, whatever it is, we pull it down. So now the 0 will be, excuse me, this became too long. Great. So I pull the 0 down. Now I'll consider these 5 bits and I divide it by g, so I end up here having a 1, simply because the part of the information that I have here that consists of 5 bits starts with 1, so dividing it by g will yield a 1. So I multiply this 1 back into g, which will simply copy for me g into this field. Okay. Great. So this is my g once again. So we carry out the XOR operation. From which direction, it doesn't matter. Great. Next we drop this 1 down, so I might want to put another arrow there for clarity. Okay. Great. So I pull down the 1 from there. Now I consider these 5 bits, or this sequence of length 5. Then I divide it by G. Because it starts with a 0, the answer will be a 0, a clear 0. And when I transform it back, I have here 5 zeros when I multiply it back. Great, so we carry out XOR once more. So we have 0, 1, 1, 1, 1. It's getting interesting. Great. So the next thing we do is that we will drop this 0 down there. Okay? When I drop it down, let me put the shape, the arrow, just this is for clarity and visual. It's a visual effect only. Okay, so here I'll put this. Now I'll consider these 5 bits, and when I divide it by G, because it starts with a 1, the answer will be 1. Okay, so I repeat the multiplication of 1 into G, I get G itself. Great. So now we will do the XOR 0, 1, 1, 0, 1. Now, because the length of G is 5, here I would need to pad 4 zeros. 1, 2, 3, 4. Okay? We are padding 4 zeros. This is simply because the remainder vector will have a length of 4, which is G minus 1. And that remainder vector R will eventually be placed at the place of these 4 zeros. Eventually, before D is sent over the channel, R is padded to D such that we have D plus R. So in fact, these 4 places, they are reserved for R. Okay, this is the mechanism how it works. Great. Now we have done the XOR operation. I'll pull down the 0 from there. So I'll simply pull down this 0. Sorry, sometimes I insist on doing visual things, it gets demolished. But so I continue and I put the 0 down there. So I have this 1, 1, 0, 1, 0 divided, because it starts with a 1, so the answer will be 1, and 1, 0, 0, 1, 1. So now we do the XOR once more, and then we drop the next bit. So we drop the next 0. Okay, now this is my sequence. When I divide it by G, I get another 1. When I multiply it by G, I get G itself. 1, 0, 0, 1, 1. Okay. Now when we do the XOR operation, we get 0, 0, 0, 0, 1. Great. So I'll pull now the next 0 from the top. It's that 0 which will come down now. I'll put it there, and naturally, as you can see now, this is my new sequence. This is my divisor now. So I'm dividing this by G. Since it starts with a 0 here, since it starts with a 0, the answer will be a clear 0. I multiply that back into G. I end up having 5 zeros, as we can see. So we do the XOR operation. The XOR operation of what? Of these 2 vectors. This vector with that vector. Okay? As we did before in the many steps that preceded. Great. So now we have done the XOR. This is the result of the XOR between the previous 2 rows. So finally I'll pull down the last 0 and put it there. Okay, great. And actually you see here now I have a sequence of 5. If I divide that by G, I'll get a clear 0. Great, that's fine, everything is well. When I multiply that back, I'll get 0, 0, 0, 0, 0. Now simply, because I cannot proceed anymore at the top, I cannot do any more divisions and any more shiftings, I will simply write down, let's proceed and then let's see when we are forced to stop. Here, 0, 0, 1, 0, 0. Okay? Great. Now because I have hit the bottom, let's say I'm hitting the wall now, I cannot proceed anymore, then I'm forced to stop now. Now I am forced to stop. And I know that R should have a length equal to the length of G minus 1. G has a length of 5, therefore R should have a length of 4. I consider the 4 bits here. This will be my R. Okay? So in this case, my R is 0, 1, 0, 0, here. So this is the vector R 0, 1, 0, 0, or in binary form, simply because we discard the ones on the left, this is the binary 1, 0, 0. But do not mix it up, please. Since R, the length of R is 4, it should be 0, 1, 0, 0. Okay? Have a good day, study hard, and take good care of yourselves. Bye.